Our next lesson is called Data Distribution Shapes. When we look at the values of a data set on a dot plot, histogram, or box plot, we are looking at how the data distribution is shaped across its range. So in exercise 1, you have two data distributions that are shown below. Each one contains 500 data points. You can see across the top of the graph, it's giving you the mean and the median, as well as the standard deviation and the IQR, all things that we've learned about in prior lessons. And it's like that for both data distribution A and B. I'd like to mark on the histograms before we even start working on questions where the mean and the median are falling. So in this first one, the mean is at 29.1. When you look at the scale on the x-axis here, you're looking at 29.1 being, the scale is going by twos. So you are a mean of 29.1. So you're kind of just below, and we're going to point that and call it the mean. Over here, your mean is 30.1, so you're kind of just above. And then we'll do the median as well. So the median for the first one, data distribution A, is a little less than that, which is 28.9. And then over here, you have a median of 28.9. Okay, so I want to mark those. And then we'll start looking through the questions and kind of take a look at what we're talking about with the shape of the data distribution. So in part A, although neither are perfectly symmetric, which of the two data distributions is more symmetric? So think about what it means to be symmetric. That means you have symmetry. You can be chopped down the middle and your two halves match. So if I had to pick that, I'm going to kind of take a highlighter here and notice that this one kind of goes up and comes back down. This one goes up and comes back down, but has a little bit of this stretched out shape on the right-hand side. So if I draw that kind of in over the top, I can see a little bit easier that definitely A is the one that's more symmetric than the other. So we'll say A, and that's because we can draw a line of symmetry at about, I'd say 30 or near there. And the two sides are almost mirror images. So that's definitely the more symmetric one. When we look at B, it says, what is true about the mean and the median of the more symmetric distribution? So over there, the mean is 29.1 and the median is 28.9 for distribution A. So if I take a look at those values, that's 29.1, I'll take the larger one, and I'm going to subtract the median, which is 28.9, and I'm getting 0.2. They're 0.2 away. That means they're pretty much almost identical. When you do the same thing over here, the mean is 30.1. The median is 28.9. And when you subtract those two values, you get 1.2. So what is true about the mean and median of the more symmetric one? The more symmetric one is A. I'm seeing by doing that math that its mean and median are closer together. So the mean and median are closer together for a symmetric distribution. In part part C, it says, what effect does the right skew of the asymmetric distribution have on its mean? So let's highlight some of these words. Right skew is referring to the fact that when I go back up here and look at distribution B, I went up and down, but I had this extended portion to the right, which is the right skew that they're talking about. Another way you might see this described is the fact that it has a tail to the right. And it says of the asymmetric. So that means the one that's not as symmetric as the other, which is distribution B. So what effect does it going kind of having that tail to the right have on its mean and the median? Well, it creates more outliers and more variation. Remember, outliers you can calculate with the formula on your formula sheet to see kind of if you're more than that away, either to the right or to the left, if you're an outlier. And when you have a tail like that, there's going to be a lot more outliers than there would be in a symmetric distribution. And that means it's going to make more variation. There's going to be more differences among your data. So more outliers and variation. And what's going to happen to the mean and the median is exactly what happened. They were closer together in data distribution A. When I look in B, the mean definitely ended up increasing because of those values that were tailed off to the right. So we'll write more outliers and variation. The outliers to the right pull the mean to be higher. And higher than the median. So in part D, how can you describe the variation within the two data sets? So variation is how they differ from each other, right? So the variation in typical values is about the same. And here's why I'm saying that. When I go up and take a look, the standard deviation and at the IQR, when I look at the IQRs in particular for these two distributions, I have an IQR of 10.7 and I have an IQR of 10.6. They're basically almost the same. So here I'm going to put nearly equal IQR. So the skew in the second distribution, so that would be distribution B, and distribution B makes the standard deviation significantly higher. So the skew in distribution B makes the standard deviation, which, by the way, remember that measures the variation. So the fact that we have nearly the same IQR, that skew affected the standard deviation. We had a standard deviation of 7.5 for distribution A, and we have 9.2 for B. So that's measuring that variability there. The skew in distribution B make the standard deviation significantly higher. So I wanted to go through that example first so that when we summarize here in exercise 2, you've kind of already seen it in action. So let's kind of summarize here. We have one that's more symmetric than the other. Symmetry, being able to kind of chop it in half and have two equal parts. So distribution A is definitely more symmetric. So what does that mean about the mean and the median? If you're a more symmetric data, distribution, then your mean and median are going to be closer together than that for the asymmetric one. It says, what effect does the right skew have? So the fact that we had that kind of tail to the right in the skewing means we have more outliers up there, which is going to pull the average up and make it more significantly higher than the median, which means our variation here is changing. So they had the same IQR, but their standard deviations were quite different. That tail to the right had an effect on that. So it says very often when we discuss statistics for a data set, we need to pay attention to whether the data is symmetric or if it's skewed to the right or the left. So let's summarize here by filling in these statements. You want to make sure, and these are super important, you're going to want to star these, you're going to come back to them quite often when you're trying to decide which information you should use to answer questions. For the first letter A, it says use the mean and standard deviation to represent a data set when the data distribution is symmetric. So mean's going to be the best central tendency value to use, the average, because it's so symmetrically distributed. And that means your standard deviation is the best way to figure out the variability. When the data distribution is skewed, we want to change what we use. So for skewed distributions, we want to use the median and the IQR. So median is the typical point, IQR is the way we measure that variability. And again, that's something you kind of want to memorize and use as your rule of thumb moving forward. So next, when data sets are smaller, sometimes there can be values that lie far away from the rest of the data, known as outliers. Outliers can cause issues similar to what we saw with the skewed distribution. So I kind of referred to earlier that we have outliers. Outliers are kind of numbers that are off the path with the rest. And there's actually a formula on your formula sheet that allows you to calculate the range in which something should be. And if it's outside of that range, then it falls as an outlier. And I'm going to demonstrate that here. But I do want to make a note of that right at the top. So we're going to put a little star and say formulas for outliers are on reference sheet. So you can refer to it there and we will talk about it in here. Lucas harvests 15 tomatoes from his garden and finds their weights in ounces, shown below. So there's a distribution of tomato weights in ounces. You can see the dot plot has been created. It says use your calculator to find all the following measures. Round any non-whole numbers to the nearest tenth. So that's important. We want to round here. So we'll do a nice little review of how to get this on the calculator. Okay, so we don't have a list of numbers in front of us. We have the dot plot itself. So I'm going to go to Stat and option 1, which is Edit. If you currently have any lists in there, remember you can go up using the up arrow to L1, hit Clear and Enter. And then you can do the same thing for L2 if necessary. So I'm in L1 and I'm going to look at the dot plot and start picking the points off. So the first dot that I actually see is at 16. So I'll hit 16 and enter. Then I see a dot at 17. Then I see 3 dots, excuse me, at 18. And so on. So what I'd like you to do right now is pause the video, finish the list, then resume the video as soon as you're done, and we'll calculate the one variable statistics together. All right, so you've resumed the video, so that means you must have your list in. Make sure you have 15 values. I can tell I do because 44 is in L1, the 15th spot. And now we can review how to find the following measures together. So they want the mean, the median, the standard deviation, the first quartile, the third quartile, and the IQR. So remember, if you calculate your one variable stats, you will get this information. So we're going to hit Stat, go to the right and head to Calculate, and we're going to pick choice 1, which is our one variable stats. I put my data in L1, so I'm all set. If you did not, make sure you change your list. You can do that by hitting second and any of the numbers in the keypad to do L1, 2, 3, 4, etc. Okay. We're going to hit enter, and we are going to get all the information that we need. So the mean is 22. The standard deviation, S subscript X, is that 6.71 number, so that in nearest tenth it would be 6.7. Then if I keep scrolling, I'm going to get that other important information. Now, they wanted us in part A to record the first quartile, the third quartile, and the IQR. The IQR we'll have to figure out ourselves. We can get the first and third quartile here, but I will tell you, eventually they want us to draw a box plot on this same graph. And in order to have the box plot, we're going to need the full 5-number summary. So don't clear this out because we're going to want to get the min and the max from here to help us create our box plot. So now let's return to the notes, fill in our information, and continue on together from there. So we can fill in the information that we got off the calculator. Remember that the mean is the X with the bar over it, so that was 22. The median was 20. The sample standard deviation, so again, remember that's S with the subscript X, is 6.7 because they said to round here to the nearest tenth. So we did that. Then our first quartile was 18. Third was 23. The IQR is not listed there, but remember you get the IQR from doing Q3 minus Q1. So if I do Q3 minus Q1, I'm doing 23 minus 18, and that is equal to 5. So my IQR is 5. In part B, which value is an outlier in this distribution? Now, I think just by looking at the picture, you probably guess that it's probably 44. You've got all these numbers that are going from 16 to 26, and then all of a sudden you got 44, which seems really far away. So I'm going to circle this for now, kind of, that's on our radar. But there is a very specific way to figure this out. So I'm going to do it right next to this problem right here, and I'm going to pull the formulas right off of the formula sheet. So to find the lower outlier boundary, we are going to do Q1 minus 1.5 times the IQR. IQR, obviously, because this is skewed, right? And that formula is right on your formula sheet. We're just getting it down here so you know this is where you would use it. And then the upper outlier boundary is equal to Q3 plus 1.5 times the IQR. So if I want to figure out if this is an outlier, this outlier is to the right. So this would be the upper, right? It's the higher part of the data. So that's the formula we're going to use. We're going to do Q3 plus 1.5 times the IQR. And if I do that, that's 23. My IQR third quartile was 23. And actually, let's put those in there. Remember, this is Q3 and this is Q1. So that was 23 plus 1.5 times our IQR, which was 5. So when I plug that into my calculator, I get 30.5. And then I look at my value, and my value is 44. 44 is definitely greater than 30.5. So that means it's above the threshold. That means this is an outlier, and it's right here. So the outlier is 44. So what effect does it have on both the mean and the standard deviation? So that is way over to the right when most of your data is to the left. So if that point wasn't there, your average would be somewhere in the middle of your dot plot values. So you're talking 19 to 21, somewhere in there. What this happened for us is that we had this big number over on the side that if we add it in with all the rest, it's going to cause the mean to be higher, which means your standard deviation is also going to be higher. There's going to be more variation. So causes the mean and standard deviation to be higher. So now when we go to D, this is the part I was talking about where we're going to draw the box plot. So you want to use your 5-point summary here to make sure that you've got the right values. So I'm just going to write 5-point summary. And I'm going to write above, because I want to actually write it over here in this space on the left. So if I went back to my calculator, the min was at 16. We already know Q1 was 18. And the median we already have is 20. And the third quartile we have is 23. And then the max was 44. So we're going to draw the box plot below the numbered line since the dot plot is already up at the top. So recall how to do this. You're going to put a vertical line at your min, which was 16. And you can kind of put the points first. You have a Q1 of 18. So that's here, or that's going to create your tail. You have a median of 20. And you have a Q3 of 23. These three are going to create the rectangle in the middle with a vertical line where the median is. And then your max was 44. So we're going to draw a vertical line, and now you can see again that tail, that skewed distribution. So in the next portion, construct an interval for values that are within 1 standard deviation from the mean. So we are going to take our mean, which is 22, and we're going to subtract our standard deviation of 6.7, and we're also going to add it. So subtracting it, you get 15.3. Adding it, you get 28.7. So it's going to be anywhere from 15.3 to 28.7 ounces. So in part F, how many values, so how many of them in the data set fall within 1 standard deviation of the mean? So we'll go up to the top and we'll find about 15.3. So that's just a little bit more than 15. And then we also have to go up to 28.7. So 28.7 is kind of a little more than halfway. And we're going to circle and mark all the values that are within that 1 standard deviation. So how many of them? We count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 of those values fall there. So 14 of them. So it says, why is the answer to F unusual? Well, let's go back up and look at how much data we have in the first place. There were 15 tomatoes, and 14 of them are within 1 standard deviation. So it's unusual because it's almost all of the data. So if we were to actually make that fraction and turn it into a percentage, we'd have 14 over 15. And if you divide that on your calculator and times by 100, that's approximately 93% of the data. So that's unusual. So in part H, when specifying typical values within this data set, would it be better to use the IQR range or the 1 standard deviation interval? So as you can see, 1 standard deviation pretty much was all the data. That's not going to help me make conclusions from this data. So I'm going to go back to that statement that we made. Use the mean and standard deviation when it's symmetric. I would not call this symmetric distribution. Because of that outlier, we're actually dealing with scenario B. When the data distribution is skewed, you should really use the median and the IQR. And now you can see why. When it was skewed like this, the standard deviation doesn't give us information because it's almost all of the data. So we're going to summarize those ideas in our very last question. So we will say the data is skewed. So the IQR, which remember what the IQR even is, it represents 50% of the data always, right? Because you're doing Q3 minus Q1. So those are 2 quarters. That's 50% of the data. So the data is skewed. So the IQR is best. Almost all data falls within 1 standard deviation. Which means every piece of data is typical. Remember, it represents typical data point. And if that's the case, that doesn't really give us the right information because it's almost all the data. So since all the data falls within 1 standard deviation, it means every piece of data is typical, which does not give us information. So again, using an example to prove to you why you have to think about what you should be using in each scenario. And I would say this statement here in exercise 2 is just the summary and the most important thing from this lesson. So you have symmetric data distributions and skewed distributions. If it's symmetric, you should use the mean and standard deviation. And if it's asymmetric or skewed, you should use the median and the IQR. And that concludes our lesson on data distribution shapes.